All right. Triangle similarity. So while you guys are writing down this, I want to kind of talk about this for a second. You guys ever put your hands really far away and then bring your hand really close to your face? It's really fun, isn't it? Does your hand get bigger or smaller as it gets closer to your face? Does it get bigger or smaller? Your hand changes size? Oh, that'd be weird. But the appearance of your hand changes size, correct? Your hand does not change. I mean, it's like if you see, you're out deer hunting, you see a deer, 300 yards out. As the deer walks closer, it gets larger, right? I mean, the deer doesn't grow in size, does it? It just has that appearance that it gets bigger. And that's the idea that I want you to have in your mind when we're talking about this. When we are looking at similarity for triangles or any other kinds of shapes, all we are doing is really just changing the size of it in how close it is to you. Is it further away? Is it closer to you? I mean, the shape doesn't change. Okay? And just like your hand, if it's, at furthest out and then you're bringing it in, I mean, you don't gain an extra finger on there, do you? Or one finger disappeared, one goes longer. If this happens to you, let me know, and then I will get you the help you need. But you get the idea, right? Yes. Maybe. Kind of. Let's try this. We're supposed to show that the two triangles are similar. Now, one of the things that I would recommend doing when you do these is actually draw them out. So I've got my first triangle here, the larger one. And that turns out to be D. Oops, sorry. I said D, C, and E. Okay. What else? Other information do I know? Ooh, is this 9? Okay. Just got to make sure that I'm doing things right here. So I've got that smaller triangle then. And that turns out to be A, that is C, and that is E. And this distance here is 3, and this distance here is 5. Now, I need to know whether or not these are going to be similar. Now, the first rule that I've got here is AA, angle, angle. Well, we know that if two angles in any triangle are the same, the third angle has to be the same as well, correct? After all, they only add up to 180. So, is this angle here going to be congruent to this angle down here? Why? What's the rule that allows us to make that statement? Considering that these angles are in the same place on parallel lines corresponding. So these are corresponding angles. So we know that angle A is corresponding to angle D. They are congruent. Would that also follow through then for B and E? Should they be congruent? Well, yeah, they got another transversal. You have parallel lines, so therefore they must be congruent. So that means the triangles must be similar. Okay. So if I was on the smaller triangle and I wanted to get to the bigger triangle, how much more would I have to blow up the smaller one? Or if I was at the bigger one trying to get down to the smaller one, how much would I have to shrink the larger one? What would I have to shrink it by or multiply it by to make it bigger? What number? Double it. Yeah, you want me to double 3? Oh, multiply by 3. I want to triple it because I want to go from 3 to 9, correct? Okay, so I got to multiply it by 3. So if that rule holds through, what would I have to get over here then if I multiplied through by 3? 15. Now, if I want to check this, if these two triangles are going to be similar, the ratio of the sides should be similar. So if I have 9 over 15, that should be the same as 3 over 5. It should be equal. By the way, would 9 over 15 reduce down to 3/5? Yeah, so it does work. Okay. So I'm going to give you a bit of time here, and I want you to go and see what you can figure out here. So I need to prove that two triangles here, in other words, this triangle right here from A, C, and B, and this one down here, are similar. Okay? That's what I want. Now, in order for us to do that, we need to have at least two angles that are in the same place, corresponding angles that are congruent. So my question is, what angles are going to be congruent and why? Which one? What were you saying? Speak up, please. Nothing corresponds? Do I got parallel lines? Do I got a transversal? So, Miss Dahl, if I was looking at the parallel lines and the transversal, could you identify a couple of angles here that would possibly be the same? Okay, so which ones would they be? Oh, I see the parallel sides, I see the transversal, but I want angles. What angle in the first triangle would be congruent to what angle in the second triangle? Okay, that's probably true, but I have no idea. They aren't on the same parallel lines. They are not on the same transversal. So I don't have enough similarity there to go and do it. While it would be nice to be able to say that for B and D, I don't know that specifically yet. I can't look at it and say, hey, this has got to be the same as this. A and C. Okay, so if you want A and C, so would that mean like A over here in this triangle and C over here in this triangle? You know, because I'm looking at it like this. Would that have to be true? Why? What's the rule that we're using with the parallel lines and the transversal? Are the angles on the same side? Alternate interior angles is where we're at. So by alternate interior angles, these two angles are congruent. What about these two angles? Same thing, right? They've got a transversal, they're on a parallel line, so by alternate interior angles, I know that these two are congruent. Therefore, by AA, I know that these are going to be similar. So when you're looking at this, one of the things that I highly recommend that you brush up on if necessary is the rules for parallel lines and transversals. The parallel line and transversal usage is crazy because it's easy to deal with. Once you know that things are parallel and there's a line going through them, there's a lot of things that we can identify. So think about them in those terms. Now, give you a few moments. Here's another one for you to write down. The side-side-side similarity. You know, if you've got a triangle that's really far away, and you're getting closer to it, angles don't change. The size of it appears to change as it's getting larger as you get closer. This is the idea that we're looking at. Getting closer to something or getting further away from something. So, I've got two triangles here. Now, when we get closer to something and we get further away from something, the shape doesn't change, does it? Okay. So, first thing I want to identify is which side would go with which. UX. Okay. Okay, so we identify the vertices. Good. So that means that UV would go with what? Okay. UV would go to, wouldn't that go to XZ? U to V, X to Z. So if this is 4, that would be 12, right? If I take UW, which is 2, that should go to XY, which is 6, right? And then I should have WV, which is 3, should correspond to YZ, which is 9. Now, how much bigger is the bigger one? 3 times the size. So if I take this one, multiply by 3, multiply by 3, multiply by 3, does that work? Yeah. So what we can do here is we can look at the ratio of these sides. So if I take the first one and 4 over 12, the ratio of the next one, 2 over 6. Ratio of the next one, 3 over 9. Are these all equal? Okay. Now, could have I written them the other way and put the 12, 6, and the 9 on the top, and the 4, and the 2, and the 3 on the bottom? No, wouldn't have mattered. It all depends upon which one you're going from. Okay, larger to smaller, smaller to larger, you just write it in a different way. So, I'm going to give you a few moments, and I want you to prove that these are going to be similar. So, I want similar sides, right? So which sides go with which? Say what? Okay, so SU. So SU goes to, well, we'll put it like this, PR. That means it should be 25.6 over 16. Okay. Well, that doesn't look easy, right? See, these are ugly numbers. Those are nice numbers. Don't worry if you get ugly numbers. How did you figure this out was 3? Wasn't it just 12 divided by 4? There. So could I do 25.6 divided by 16? Yep. So let's see. Clear that out. So if I go and take that, I get 25.6 divided by 16, and I end up with 1.6, okay? So what is another? ST over PQ. So that would be 14.4 over 8. Does that work out to be exact? What? What did I put down? Oh, my bad. Yep, 9. So, let's see, 14.4 divided by 9. Well, looky there, 1.6. So would I go and hope that's going to hold out for the other two, where we have TU over QR should be equal to 8 over 5, which should be equal to, I want to get here, 8 divided by 5, 1.6. There we go. That was nice, wasn't it? Well, if the lengths of the sides are proportional to the lengths of the sides of another triangle, then these triangles are similar. So, is there a proportion, a value that multiplies one by the other? Is it all the same? Could I say that the larger triangle is 1.6 times the size of the other one? There you go. Okay. So, what happens if I want to work with this for the side similarity? Now, when I looked at this one before, it came out pretty easy with that idea that we had. Unfortunately, I think that they messed this up a little bit. It should have been that ABC is DE. Well, yeah. They should have set up the ratio that it shouldn't have been AB over DE. It should have been DX over DE. That's what it should have been. Now that I think about that a little bit more. Because if I look at this triangle over here, this angle and this angle are the same, correct? This angle and this angle are the same. So there is similarity going on there, correct? They say that this here is congruent to that there. They also tell us that, what else would they tell us here? I think that was pretty much it. So just by doing that, can I go and assume that there is going to be a ratio of dx over dE? Okay. Like I said earlier, this was a poorly written problem, but that's okay. So if I know that is the case, and I got this here, so could I say that AB would be to DE? Okay, so that gets us back to our given. And so what we can conclude out of this is that, okay, we've got these sides that are going to be the same. This thing has a ratio of AB to DE, so this side to that side. So this side here should be the same to that side there. Would you agree? That BC then would go to here, correct? So then this has to be similar to that. I mean, thing is, they gave it to us right there because of side. Okay. Granted, we're trying to prove side, but they didn't set it up well enough. But as long as you can go through and recognize what is congruent to what is similar to what, you won't have too much of a problem with this. Look for corresponding parts. That's another big thought here. So here is one more. I'll give you a few moments to write down. This one is just what it says. If you have a side and an angle and a side in that order, proportional to each other, triangles are going to be similar. So let's take a look at this. Would you agree if I did this? Would you agree with that reasoning? Mm-hmm. Okay. So that means that this side here and that side there are congruent, correct? So I should have a similarity then of ED over EX should be equal to EF over EY. That makes sense to say, correct? So I need one more thing, don't I? Is angle E in both triangles? So do I have enough information there after I go and say that angle E is congruent to angle E, right? Do I have enough information there to state that those two triangles are similar? Most definitely. So what about this? It tells me that EX is 6, ED, so from here all the way over here is 11, and it tells me from X to Y, that is going to be 7. I'm supposed to find DF. Do I have enough information to figure this out? I suppose I could go and add in a little bit more, that if that's 6, this is 6, right? If that adds up to 11, this has to be 5 and this has to be 5. Does that really help me? Which is more information, but not necessarily. Because what should happen here is 6 and 11 should be equal to, let's see, 7 and DF, right? Because that's what I'm looking for, is down here. Did I set that up right? So what should DF be then? 11? Well, couldn't I just use that little trick that I had shown you guys before, where I can take 7 times 11 divide by 6, 12.833? So that means that this distance over here would be 12.83 repeating. Easy enough, right? Okay, so set this up and see what you can figure out. So, anybody notice anything? What'd you notice? Hmm? How do you know they're similar? What ratio? Oh, I don't want. Aaliyah, did you notice anything? Like what? absolutely correct. Excellent. When we figure out which ones go with which, so if these are similar, and I've got smaller and larger, that would imply that the 4 goes to the 8, correct? That would imply that the 5 goes with the 10, this goes with the 13. And we see that there's a multiple of 2. So that kind of implies that if I've got 2x plus 3, if I were to multiply that by 2, should that not equal 13? Okay. Now, if you can get to this point, the rest of it's just algebra, and it's fairly easy. Divide both sides by 2, divide both sides by 2, so we have 2x plus 3 is equal to 6.5. Subtract 3, 2x is equal to 3.5. Divide by 2, and x is equal to 1.75. Okay. Make sense? But it's really identifying what is that multiplier, what goes with what. Now, how this would actually get used, and it was used in this fashion, actually, when they went out and surveyed the United States. Works out rather well. Now, a surveyor needs to find the distance across the lake. Surveyor makes the measurements as shown. Find the distance across the lake. So, what they did is they just simply pick a tree or point whatever on the opposite side of the lake. They pick one over here. They get their lines of sight measured in, and they figure out another line that they were able to do on the shore, which is what they did here, 20 meters and 25. Then they had another line that was parallel on the same bearing, which made life a lot easier because that became congruent, right? And because this line is parallel to that line, this angle here is congruent to that angle over there. So we've got alternate interior angles and vertical angles there. So we know that we could set up the ratio of 20 over x should go to 25 over 100. Well, I suppose if I didn't want to do it that way, I could have done it this way. 20 over 25 is going to be equal to x over 100. Same thing, only different, right? So, how far is it across the lake? 80. Yeah, just multiplication by 4. And they always tried to use easy numbers like this, make life a lot easier for them when they're trying to do their calculations. So that means across the lake would have to be 80 meters. It's not really a big lake, is it? More like a puddle. So, what I want you to do, I want you to work on this one. I'll give you a little time to play with this. See what you come up with. So what would it actually measure, or would it actually matter what time of the day you did this? No, a shadow is a shadow is a shadow, right? I mean, it doesn't matter if the sun is directly overhead and you have a small shadow, or if it's rising or setting, you just have longer shadows. So that really wouldn't matter too much with it. But yes, you are correct in that time is going to matter. You wouldn't want to go outside at noon and measure the shadow of the tree, and then 5 hours later go back out and measure your shadow. That would not work. It would have to be done at the same time. So that's kind of why when we do these things, we always want to try and draw out a picture of what's going on with it. So I've got that going on here. Let's see, we got to have a tree. Got my tree here. See, then I got to have a house in the tree, don't I? Well, that's kind of the whole thing here. So there's my tree house. Right? So there's my tree house in the tree. I never said it was a good drawing, but you don't have to really worry about that. Now, of course, then there is going to be We got to have Laura, right? Now, we got the sun sitting up here someplace, right? And what it's doing, it's looking at the top of the shadow of the tree house. So we're looking at the rays of the sun that are coming through here and casting out the shadow, correct? So here's her shadow, or here's the shadow that we were trying to pay attention to. Okay. Now, that shadow is how long? That shadow is 25 feet. Now, one of the ways that you could do this is Laura could have been standing right about here. And when she was looking at how long her shadow was cast, her shadow cast was what? 6 feet 2 inches long. Okay, that's what hers was. Now, does she also know how tall she is? She is also the height of 5 feet 8 inches. Now, for this, is it important for us to switch everything into one measurement? Everything in feet, everything in inches? We don't want feet and inches, do we? That would be a little messy. So let's see. So if I said that Laura she's 68 inches tall, right? And she had a shadow that is how far? How many inches? 72? Oh, that's 74. Right? Because she's 6 times 12 is 72 plus 2 more inches, so that would be 74. Now, mind you, this is in inches, and that's fine. We know what the ratio has to be. Now, this is going to have to be equal to whatever it is over here. So if this is 25, that would have to be feet, right? This would have to be feet down here, correct? Is that legal to do? And the answer is yes. So what's 25 times 74 divided by 68? And we work this out. Turn this on, put it out. So we get 25 times 74 divided by 68. And I end up with 27.2. Okay. So that means that this thing is going to be 27.2 feet. Okay. How tall is the tree? I still don't know, do I? She notices that the tree makes a shadow on the ground. The top of the shadow of the tree house is 25 feet away. So that would really only give us this much, right? So that means that the height of the tree house would have to be 27.2. Do we know how tall the tree is? Absolutely not. But I do know how far the tree house is off the ground. Actually, no, the top of the tree house is. Who knows? It could have been a 2-story tree house, right? So, but draw yourself out the picture, label, and life will be a lot easier when it comes to working on these problems. So that when you get errors like this, you're able to go through and figure out what's going on. So, questions? Hey, well, get to work, and the assignment is due at the end of class tomorrow.